Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving into the fascinating world of biomachining. It's a truly unique approach to metalworking, using bacteria to, get this, machine metal.
Biomachining? That sounds incredibly unusual. I mean, bacteria? How does that even work?
That's the beauty of it. It leverages certain lithotrophic bacteria, like Thiobacillus ferroxidans and Thiobacillus thioxidans. These guys are already used in bioleaching, a mineral refinement process. They essentially eat metal, using the chemical energy from oxidizing iron or copper to fuel their growth.
So you're saying they literally consume the metal? That's wild.
Precisely. You place a metal object in a culture fluid teeming with these bacteria, and over time, they remove material from the surface. It's a remarkably slow process, which is why it's ideal for micromachining. The low material removal rate ensures incredible precision.
Interesting. So no harsh chemicals or high-powered tools needed? What about the surface finish?
That's another advantage. Because the material removal isn't concentrated in a small area like with traditional machining, you're less likely to get a damaged or burned surface. It's a much gentler process, resulting in a superior finish. Think of it as a biological polishing.
Amazing! But how do you control the process? I imagine it's not just throwing a metal part into a bacterial bath and hoping for the best.
Oh no, it's more sophisticated than that. It's similar to chemical milling. You use a mascant to protect the areas you don't want to be machined. Then, the part is submerged in the culture fluid, which is kept at a precise temperature and stirred. The stirring rate, along with temperature, actually affects the depth of the cuts. Fascinating, right?
Completely. So it's a very controlled biological process. Has this been used successfully on anything beyond lab experiments?
Yes. It's been successfully used to cut both pure iron and pure copper. The research is still ongoing, but the potential applications are huge. Imagine the possibilities for microfabrication, creating incredibly intricate structures at a microscopic level.
This is revolutionary. It's a completely different paradigm for machining. I'm curious though, what are the limitations? Is it only suitable for certain metals?
That's a great point. Right now, the process is limited to certain metals, and the speed is, as we discussed, quite slow. But the potential for expansion is enormous. Research is ongoing to explore other bacteria and metals. It's still early days, but the future looks bright.
Absolutely. It's a testament to the power of bio-inspired engineering. Thanks for shedding light on this incredible technology.
My pleasure. And that's all the time we have for today's Tech Bytes and News. Thanks for tuning in, and we'll see you next time. Goodbye.
Bye-bye.